Thanks for watching this screencast. Our objective for this screencast is learners will be able to solve a system of equations by elimination. So by now you've probably seen the screencast on solving systems by graphing. You've probably seen the screencast on solving systems by substitution. Let's tackle that third process of what we call elimination. The goal of the elimination method is to find one way, either by straight up adding the equations together or by multiplying one or both of the equations first, but to find one way to cancel out or eliminate either the x or the y term, to create a new equation that only has x or y in it, and then you can solve it by a process similar to what we saw with substitution. So in this first example, Panthers, we want to solve the system 4x plus y equals 16 and 3x minus 2y equals 23. And what I'm looking for is there a way to, even if I have to multiply one of the equations by something first, is there a way to create opposite x's or y's? So what I see is that in this top equation, if I were to multiply that first equation by 2 and to leave the second equation alone, I'll abbreviate it like LA, leave alone, what I would then create is a new system. I'll do it over here. Not 4. If I multiply the top equation by 2, I get 8x plus 2y equals 32. And if I don't do a thing to the bottom equation, I've got 3x still minus 2y equals 23. And I hope you see that if I were to add those equations together, you like add here, what would happen to the y's is they would cancel. They would become 0. All I'm left with is 11x equals, I think, 55. And I can pretty quickly tell you what x has to be. If I divide both sides of this equation by 11, x is 5. Now from here, the step to find y is a lot like with substitution. I need to pick one of my equations, and I need to use the fact that I know that x is 5 now. I think I'll take the top one here, and I'll write 4 times x is 5. X is 5, so 4 times x is 4 times 5, plus y equals 16. 4 times 5 is 20. And if 20 plus y is 16, y must be negative 4. Because 20 plus negative 4 is 16. So what's my solution? 5, negative 4. Good. Here's another example. I want to emphasize the fact that it seems, at least to me, that by far the most challenging part of this task is finding your strategy for getting either the x's or the y's to cancel out. What I think I see in this example is that I'm not going to be able to only multiply one of the equations by something. I think I'm going to need to multiply both. You know, since 2 doesn't go evenly into 3, and since 4 doesn't go evenly into 5, I'm going to need to find some way to eliminate either the x's or the y's by multiplying both equations. And I also think you could probably work this a couple of different ways. One of you might be thinking about trying to eliminate the x's right now, and the other might be thinking about the y's. I think I'm going to try and eliminate the x's, but if you try to do it with the y's, you would get a different process that still works, I believe. I'm going to choose to multiply the top equation, I'm thinking by 3. And I'm going to multiply the bottom equation by negative 2. Do you see why that's going to work? That's going to give me 6x on top, and it's going to give me negative 6x on bottom. And I should be able to cancel those out. You could also have done this by doing negative 3 here and positive 2 here. I think you also could have gotten rid of the y's by multiplying the top equation by 4 and the bottom by 5. There are a lot of ways to solve this problem, but let's do it. The top equation times 3 is going to give me 6x minus 15y equals 9. The bottom equation, if I multiply everything by negative 2, gives me negative 6x minus 8y equals negative 32. And now, if I add these two equations together, what I'm going to see is the x's are going to go away. I've got negative 23y equals 9 minus 32 is negative 23. And if negative 23y is negative 23, y must be 1. Now I've got to pick one of the original equations to find x. I think I'll pick the top one because the numbers are a little bit smaller. So 2x minus 5 times y, which we know is 1, right, equals 3. And 5 times 1 is 5. I've got 2x minus 5 equals 3. If I add 5 to both sides, make sure you add 5 to both sides, I get 2x is 8, or x is 4. My solution here is the ordered pair 4, 1. It's your turn. Panthers, pause the video, see if you can solve this by elimination, and then check back. I see two ways you could do this at least. The way that I immediately locked onto was the idea that I thought if I multiplied the top equation by 5, and if I left alone the second equation, I would get y terms that cancel, 5y and negative 5y. So that's my plan, and it may not be the same plan you had, but let's kind of check it out, see if we both didn't end up in the same place. So I've got 20x plus 5y equals 10, and the second equation that I didn't touch, 2x minus 5y equals negative 32. If I add those two equations together, the y's are going to cancel out. I've got 22x, which equals a negative 22. I know what x is. X is negative 1. And now that I know x is negative 1, let's go back into one of the equations. I'll pick this one because I think the numbers are smaller. 4 times x, which is negative 1, plus y equals 2. Another advantage for this one is that you're just going to get y. You could probably get y in about 2 steps. 4 times negative 1 is negative 4. If I add 4 to both sides, I can show you that y is 6. Our solution here is the ordered pair negative 1, 6. And even if you didn't use the same strategy I did here, did you get the same answer? I hope so. Thanks for watching.